Let's continue talking about solving triangles or finding missing sides or missing angles of triangles. Now, things that we've looked at so far. Again, we've used right triangles. So we know if we have a right triangle, we could use trig ratios, we could use Pythagorean theorem, lots of nice things we can use there. We just spent quite a bit of time practicing and talking about the law of sines. Law of sines can be used. So just remember from the last section, the law of sines can be used if you have an opposite side angle pair, okay? What if you don't have an opposite side angle pair? Then we're not going to use those ratios of the sine of an angle to a side with the opposite angle and side. We can't do that. So in this case, what we're going to need is the law of cosines. So we do not have a right triangle, and we cannot get an opposite angle side pair in any way easily. So what the law of cosines says is if you have any triangle A, B, and C, where the opposite of angle A is side A, angle B side B, angle C side C are opposites of each other, then what we end up with is, if you're solving for a side, you can think of it as C squared equals A squared plus B squared minus 2AB cosine of C. Remember, lowercase a, b, and c are sides. The angles are uppercase. Not only that, but notice the relationship here. Side C is being squared on a side all by itself. And the angle inside the cosine is angle C. These guys right here are opposites of each other. And the other sides involved are the two other sides of the triangle, okay? That's in that setup. You could take the same equation, okay, and you could write it as cosine of C is equal to A squared plus B squared minus C squared over 2AB. It's the same equation, but in this case, it's dealing with the angle, the cosine of the angle being on one side. Notice the relationship. The cosine of the angle is on one side alone. The side that's being subtracted is the side that corresponds. They're opposites of each other. So for the formula's sake, I'm using C, side C or angle C. You could use the same relationship for any side A or any angle A as you go through, okay? It's very similar to the Pythagorean theorem. You almost see, and let me see something here, yeah. You almost see the Pythagorean theorem built in here, right? This is for any triangle. If you had a right triangle, okay, think about the Pythagorean theorem. It says A squared plus B squared equals C squared, where A and B are your legs and C is your hypotenuse, okay? That's what we had for that. Well, think about what it would be with the law of cosines. Law of cosines says that side C squared is equal to A squared plus B squared, sum of the other two sides, minus 2A times B times the cosine of C. Cosine of C is the angle that is opposite side C. Well, that's a 90-degree angle. Cosine of 90 degrees is 0. So we're subtracting 2 times A times B times 0. That's just 0. We're subtracting 0. That leaves us with C squared equals A squared plus B squared, the Pythagorean theorem. It's just a special case of the law of cosines, okay? But this is our law of cosines. These are the two forms that we're going to use as we go through all of our problems, okay? Let's go ahead and dig in and look at some examples. After this, I will have some problems that you could either use law of sines or law of cosines. Knowing which way to deal with it is important. If it's a right triangle, grab Pythagorean theorem ratios. If you know an opposite angle side pair, grab the law of sines. That's going to be the quickest. And if you can't get an opposite angle side pair, use your law of cosines. And think about that as you approach all of these problems, okay? So, let's look at this example. All right. I want to find angle theta in this diagram, given this diagram. So when I look at this, okay, let's look at what we have here. We have a length of 68.01, we have a length of 37.83, and we have a length of 43.15. I know my angle at, or my side A, that's opposite of A, that's 68.01. I know side B is 37.83, and I know side C is 43.15. I know no angles. So since I don't have any angles, I definitely have no opposite angle side pairs. I have a triangle where I only know the three sides. A side, side, side triangle. I don't know any angles. So I can't use the law of sines, which is what we had done before, okay? I can use the law of cosines. What are we wanting to find? We're wanting to find angle theta. Notice that angle theta is the same as our angle B, okay? So anytime we want to use an angle, we don't have an opposite angle side pair, then I'm going to use the version of the law of cosines where if I'm needing to solve for an angle, I use the one that has the angle closest to being alone. The formula that you were given just a second ago said the cosine of C is equal to a squared plus b squared minus c squared over 2ac, where this angle and this side correspond to each other. I'm wanting angle B though. So I'm actually going to use the form of it where I have the cosine of angle B is equal to, okay, so my other two angles would be a squared, so a squared plus C minus, since I have angle B, I want side B being squared being taken away, over 2 times the product of those two angles, okay? This is the same as cosine of theta. So cosine of theta is equal to a squared, my A is 68.01, C squared, that's 43.15 squared, minus B squared, 37.83 squared, over 2 times A times C. So there's my substitution in the formula. And that means that theta is going to be the inverse cosine of this whole big old fraction. Okay, that whole big old fraction. Now, calculator-wise, we can do this a couple of ways. Excuse me, I'm losing my voice a little bit. Let me grab the calculator. All right, so calculator-wise, we can do a couple of things. We can type the whole big mess in. I can go inverse cosine, second cosine. And I can do this whole big old thing. So if I want to type it all in, I'm going to need parentheses around the numerator. So I have parentheses, 68.01 squared plus 43.15 squared minus 37.83 squared. That's my numerator, so I'm going to put my numerator in parentheses, divided by my denominator in parentheses. So I have parentheses 2 times 68.01 times 43.15. Close off my denominator, close off what's inside inverse cosine. So I can type the whole big old thing in, and I end up with theta being 30.518, so on. Now, you can also simplify what was inside first. So you could go in here and do this whole mess. We had 68 point, whoops, let me go in here, type it right. 68.01 squared plus 43.15 squared. And see, I'm typing on a touch screen with this, and sometimes I have to watch myself. Okay, come on. There we go. Minus the 37.83 squared. But remember what I've said all along, I don't like to round. So this is my numerator. There's my numerator. Divided by, in my denominator, I'm going to have 2 times 68.01 times the 43.15. This is what's inside my inverse cosine. So I've evaluated the fraction. Now I need to take the inverse cosine of this answer. So I'm going to go second cosine of that answer, and I get 30.518, the same number I got when I typed it all in at once. Everybody's a little different in how they deal with those. So just think about how you are most comfortable typing things into your calculator. But you get the 30.518. So I'll go ahead and go to the nearest tenth. That angle, theta, is approximately 30.5 degrees. My calculator was in degree mode, so my angle was approximately 30.5 degrees. Notice this problem did not ask us to find anything else except for that angle. So I didn't have to go any further and find angle A or angle C for this one, okay? But that's what I would have there. Let's look at another example. Remember, you can always pause, take a break, come back, stop it, try an example, come back, check yourself. I'm just kind of running through these here. I'm trying to get this to clear up as much as possible. Oh, come on. This thing does not want to behave. It's getting fuzzy. Let's look. Okay, you know what? Let me see if I can clear it up a little. Does it not like the writing? Okay, guys, just a second. Let me get this to focus. In fact, let me pause the video and I'll get to focus and then I'll be right. Okay, now I got it to refocus so you can actually read the writing. Let's look at this one. In triangle ABC, side A is 10, side B is 13, and angle C is 70 degrees. We want to find the missing side rounded to 2 decimal places. So we want the missing side. We have side A and B, so that means what we're wanting for this one is to know what is C equal to. Side C, what's it equal to? Well, as we look at this, we don't know if we have a right triangle. Most likely we don't, but we don't know. So we can't use right triangle trig. But what we can do, well, first of all, do we have an opposite side angle pair or a way to get it? Nope. I have angle C, but I don't know side C, and I don't have either of my other angles to know an angle opposite of side A or B. So we're not going to use the law of sines. we're going to go ahead and we're going to jump to the law of cosines. Okay. Now, we have two versions of the law of cosines. One of them involves finding a side. We're looking for a side. So when you're wanting to use this to find a side, you're going to use the version that is c squared equals a squared plus b squared minus 2ab cosine of angle C, okay? Do we have enough information to use it? Now, we do want side C, so this form of it is exactly what I want. The side should correspond to the angle inside cosine, and the A's and B's should be the other two sides that are known. We have enough information here. C squared is actually going to be equal to A squared, A is 10, so that's 10 squared, plus B squared, B is 13, so that's 13 squared, minus 2 times A times B times the cosine of C, and C is 70 degrees. So we have all of this. Now, you can go ahead if you want to. We're solving for side C. We have C squared equals. When we're solving triangles, you're not going to have negative sides, so we don't have to worry about a negative here. C is going to be the square root of this whole big old mess. Okay? So, you can either do the whole thing and then take the square root of the answer, or you can type in the whole big old thing, just don't round till the end. So we have the square root of 10 squared plus 13 squared minus 2 times 10 times 13 times the cosine of 70. And so C is equal to 13.419, so on. The problem said round it 2 decimal places. So I want to go 2 decimal places. My next digit is a 5 or larger, so I'm going to round up. So C is approximately 13.42. And that would be my answer. Now, I've taken care of what the problem asked me to find. I don't have to go further. If I wanted, so I'm done. This is where I'm done. Okay, I'm done. That's the answer. I don't have to go any further. Okay. If you were asked to solve the triangle and you also needed angle A and angle B, then you could use your law of sines, because you know angle C is 70 degrees, and now you know side C is 13.42. So you have an opposite angle side pair, and you could continue to solve using the law of sines, okay? But for this problem, we didn't want to go further. We're done. It is very rare to use the law of cosines more than once, okay? If you need law of cosines, you should only need to use it once. Let's look at a couple more examples. All right, let's look at this word problem. Give you a second. Well, you can always pause it and look at it. I don't need to stop. 125-foot tower is located on the side of a mountain that's inclined 32 degrees to the horizontal. A guy wire is attached to the top of the tower and anchored to a point that is 55 feet downhill from the base of the tower. Find the shortest length of wire needed. So let's just kind of sketch out the situation that we have here. We have a hill like this. And somewhere on the side of this mountain, we have a 125-foot tower. Okay, so we have a 125-foot tower. It's inclined 32 degrees to the horizontal. The mountain is inclined 32 degrees to the horizontal. So if you imagine kind of flat ground, it's inclined 32 degrees with the horizontal. The mountain is. Now, what else do we know? A guy wire is attached to the top of the tower and it hits the ground 55 feet downhill from the base. So if I go 55 feet downhill from the base and attach the wire from the top of the tower there. So this is my tower, this is my wire, okay? So we look at that. Hello. Sorry, I have a little bit of company here. Hello, say hello. Okay, sit down. All right. So we have this situation. We have the wire. Now, let's look back here. Do I have all the information given there? What's the shortest amount of wire needed? We're interested in the length of the wire. So that's this distance right here, X. That's what we're looking for, okay? Notice that I have a triangle up here. I'll kind of sketch it out to the side. I have a triangle up here that has a length of 125 feet here, 55 feet here. I know this is not drawn to scale, and an X here, okay? Well, I don't have three sides. If I knew at least one angle, I could use law of sines or law of cosines to do it. Let's kind of look at the situation. Imagine if I continued the tower down to the ground. That creates a lower triangle down here that's a right triangle. So I know this is 30 degrees and this is 90 degrees. So I can get this angle right here by going 180 minus 32 minus 90. So 180 minus 32 minus 90 is 58 degrees. So I know this angle right here is 58 degrees. Notice that it, along with this angle here, would form a straight line. So I can get this angle here, since they form a straight line is 180 degrees. So I can get 180 degrees minus 58 degrees. And that angle there is 122 degrees. So I know this angle right here is 122 degrees. Look what's happening in this. I don't know an opposite angle side pair. I don't have the angle opposite the 125 or opposite the 55. I don't have the side opposite the 122 degrees. I'm going to have to use my law of cosines, where I'm solving for a side. So that's the version c squared equals a squared plus b squared minus 2ab cosine of c, angle C. Well, the side is x. It's opposite 122 degrees. So my x squared, my angle is 122 degrees. A and B represent my other two sides. So I would have x squared equals 55 squared plus 125 squared minus 2 times 55 times 125 times the cosine of the 122 degrees. There's my setup. I don't even have to label them A, B, and C. I could. I don't have to. In my formula, I let c squared be x, so I could say, okay, this is side C, so that means this is angle C. And then I could say if this is A, that's side A. If this is B, that's side B. I could do that, but you don't have to. So as we go through and do this, that means x is going to be equal to the square root of all that mess. So I have square root of 55 squared plus 125 squared minus 2 times 55 times 125 times cosine of 122. And that is 161.04, so on. That's that side X. X represented the length of wire needed. So we're going to need at least 161.0 feet of wire. I mean, if we had more, we would just not use it all. But that's the amount we're going to need for the guide wire. Okay? Okay. Let's go through and look at another one. If you have an application, drawing a sketch of what's going on is always great as you go through to do those. Okay? One more application of the law, of direct application of the law of sines. Lots of times we can talk about things called bearings. If you've ever heard of something moving, if you've ever done a compass, traveling northeast or traveling southwest or anything like that, that's using something called bearings. So let's look at this situation. Two boats leave the same, and my writing got really jumbled there, leave the same port at the same time. One boat travels at a speed of 30 miles per hour in the direction of north 50 degrees east. The other travels 26 miles per hour in the direction of south 70 degrees east. How far apart are the two boats after 1 hour? Well, let's look at the situations going on here. Again, if you can ever draw a sketch, that is fantastic. Now we're talking about directions, northeast, southwest. So imagine going north or south, east or west, okay? Here's our port where the boats leave. All right, boat 1 leaves the port and travels north 50 degrees east. What that means, north 50 degrees east, means that if you go to the north and then 50 degrees to the east, that's going to get your angle. So you're going northeast by 50 degrees, okay? So north to the east, you're going north to the east by 50 degrees. That's giving you that angle there. That's the first boat. I'll just say boat 1, okay? Now, that length from the port to boat 1, we know that boat 1 travels at 30 miles per hour. So in 1 hour, it's traveled 30 miles. Because it's 30 miles per hour, in 1 hour, it's traveled 30 miles. So I know this distance here is 30 miles. Now, what's that mean? If it had traveled for 2 hours, it went 30 miles in an hour. So in 2 hours, it must have gone 60 miles. 3 hours, it would have gone 180 miles. The key there was the 1 hour, okay? Now let's look at boat 2. Boat 2 travels at 26 miles per hour. So in 1 hour, that means it traveled 26 miles. So it didn't go quite as far. And its direction was south 70 degrees east. So south to the east by 70 degrees, it's going to be somewhere here. South to the east by 70 degrees, okay, is right there. And it traveled for 26 miles. So the length of that is 26. And there's boat 2. The problem says, how far apart are the two boats after 1 hour? So we're looking for the distance between these two boats. That's our unknown, okay? So notice what we really have going on here is this triangle where we have this side coming up like this side coming down like this, roughly, we have this. There's boat 1, boat 2, the port, okay? This is what we're looking for, X. I know this distance is 30 miles. I know this distance is 26 miles. Do we know an angle? We actually do, because notice north and east form a boxy 90-degree angle. So since this is 50 degrees, this part right here would be 90 minus 50 would be 40 degrees, okay? South and east form a boxy right angle. We know this part is 70, so we can get this part right here. 90 minus 70 is 20, so that little bitty angle there is 20. So that means that in this triangle, this angle right here is made up by this 40-degree angle and this 20-degree angle. So that is 60 degrees. So we do know an angle in there. This is the situation we have, okay? This is a 26, my numbers got jumbled there. We have no opposite side angle pair. So we're not going to use our law of sines. There are bearing problems where you could if you had an opposite angle side pair. I'm going to use my law of cosines. So I'm going to jump to, excuse me, my law of cosines. I'm looking for a side, so I'm going to use the form of it that c squared equals a squared plus b squared minus 2ab cosine of c. This side is opposite 60 degrees. So I'm going to have a cosine of 60 degrees in the problem and x squared equals. Those are my opposite angle and side. A and B represent my other two sides. So one of them is going to be 30, one of them is going to be 26. So I have 30 squared plus 26 squared minus 2 times 30 times 26 times cosine of 60. So the distance between the boats, x, is going to be equal to the square root of 30 squared plus 26 squared minus 2 times 30 times 26 times the cosine of 60 degrees. Now, yes, 60 degrees is one of the nice things that we knew from the unit circle. We know that the cosine of 60 degrees is 1/2. So if you wanted to go ahead and make cosine of 60 degrees 1/2 in your formula, that's fine. But we're going to use the calculator anyway, so I'm just going to leave it as is. 30 squared plus 26 squared minus 2 times 30 times 26 times the cosine of 60. And this gives me 28.213. The problem did not say how far to round. I'll go ahead and take it one decimal further than the original. So the two boats are approximately 28.2 miles apart, okay? We were able to use the law of sines to go through with those. The whole idea of northeast, northwest, southeast, southwest, we always start north or south and then go either east or west from that direction. So the angle that you're being given in between is really an angle between your y-axis and whatever side you have that's creating that angle, okay? So those are some law of cosine problems. We do have one other application of the law of cosines that we can talk about. Now we know that if we have a triangle where it doesn't have to be a right triangle in itself, but if we know the height of the triangle and the base of the triangle, we can get the area of that triangle to be 1/2 the base times the height. But we don't always have the height given, and it's not always easy to find the height in what you have given. So Heron's formula is going to be where you can deal with a triangle where you know your three sides, but you don't necessarily know the height. So we're not going to use area equals 1/2 base times height, okay? Now, if you want to see Heron's formula derived, I will happily do that for you. Just let me know. I'll either do it, send you a video of it, of me deriving it. It is lengthy. Or I can also go through and I can give you, there are lots of YouTube videos, lots of things out there where it's derived before. And it is based on 1/2 times base times height. But here's the deal. In order to find the area of any triangle where you just know your three sides are your A, B, and C. This is the formula using Heron's formula. Area equals a big old square root. S times S minus A times S minus B times S minus C. A, B, and C are my sides. S is what we refer to as the semi-perimeter. It's half the perimeter. Remember, to get a perimeter of a triangle, you add the three sides. The perimeter of any object that has straight sides enclosing it, you add up the sides. So S is the semi-perimeter, okay? This is the formula that we can use to find area of any triangle if we know the sides. So keeping this in mind, let me go through and just do an example using Heron's formula, okay? A businessman wishes to buy a triangular lot in a busy downtown location. Triangular lot, kind of rare to have that gathered, but it can happen. The lot frontages on 3 adjacent streets, so it's enclosed on 3 streets that have lengths on those adjacent to those streets of 125 feet, 280 feet, and 315 feet. Find the area of the lot he's going to purchase. We don't have a diagram, we don't know what's going on, and we don't have to. We know our 3 sides. So I'm going to let A be the 125 feet, B be the 280 feet, C be the 315 feet. So to use this, I need the semi-perimeter, which is S, which is 1/2 of the perimeter. So that's going to be 1/2 of the sum of these 3. So if we take 125 plus 280 plus 315, and we multiply it by 1/2 or divide it by 2, that means our semi-perimeter for this is 360 feet. The formula for the area of a triangle by Heron's formula is you take a big old square root of that semi-perimeter times the difference between the semi-perimeter and A, times the difference semi-perimeter and B, times the difference semi-perimeter minus C. You want to say hello? Say hello. Okay, so we're going to go ahead. I think after this example, I'm going to have to go play ball for a few before I do another video. Okay, so we know what S is. It's 360. Always start with the semi-perimeter, not the side itself. So A was 125, so I'm going to go 360 minus 125 times 360 minus the 280 times 360 minus the 315, okay? I'm going to do this big old thing. You can simplify what's underneath first if you want to, or you can just do the whole big old square root. Be careful as you do this that you have the order of the subtractions correct. It will cause a problem if they're not. And also, just be careful. Lots of times when you're typing a lot of numbers in the calculator, it's easy to accidentally get a decimal or accidentally skip a number. But this is 17,451.647, goes on forever. We're looking at the area of the lot. The sides are in feet. Area is always square units. So the area of the lot is approximately 17,451. I'm going to go ahead and go to the 10th. 0.6 square feet. Okay, that's the area of our lot. And so that uses Heron's formula. It can be used in so many types of applications. So go ahead and make sure you've tried those. In your notes, do those try problems. There's a whole bunch of them in this unit, and I'll do a video again that has the solutions for those. The answers are in your notes. Try your homework, see what types of questions you have, and let me know. Somebody is standing here with a ball wanting me to play fetch, so I think I'm gonna go play fetch for a few. Shoot me an email if you have a question. Have a good one.